You hear the term IT thrown around all the time, right? Information technology. But what does that actually mean? I promise you, it's so much more than the help desk or fixing a printer. It is the invisible, digital architecture that our entire modern world is built on. So today, we are going to pull back the curtain and demystify IT, starting from its tiniest building blocks all the way to the global systems that connect every single one of us. Let's jump in.
So let's just ask the big question right up front. What is information technology? It's so easy to just think of it as, computers and troubleshooting, but the real answer? It's so much bigger and more fascinating than that. It's the entire ecosystem that powers our digital lives. So here's how we're going to tackle this. First, we'll get a real handle on what IT actually is. Then, we're going to dive into the secret language that all machines speak. After that, we'll look at the physical hardware that uses that language, the software that acts as its brain, and of course, the networks that connect everything together into one giant web. By the end, you'll see exactly how these pieces create the world we live in right now.
Okay, let's get right to it. At its very core, IT isn't just one thing. It's the entire system. We're talking the tools, the processes, the people, the whole shebang. That's all dedicated to creating, storing, and sharing information electronically.
But when you look at the formal definition, whoa, it gets big fast. Look at those words: coding, data communications, systems analysis and design. This tells you that IT isn't just about the physical equipment. It's this massive, sprawling field that covers everything from the silicone chips to the abstract logic that actually makes them do something useful. To really get a handle on IT, you've got to start with the I, the information. I mean, how do you take our complex, messy, beautiful world and translate it into a language that a machine can actually process? Well, it all starts with one fundamental idea.
And this is it. This is the core concept: analog versus digital. Think about an old vinyl record. That groove cut into the plastic is a continuous, physical analogy of the sound wave itself. It's analog. But a CD or an MP3 file? That's totally different. It takes thousands of tiny snapshots of that sound wave every second and stores each one as a distinct number. It's discrete, it's digital, and our modern world is built on digital.
So, how do computers actually speak this digital language? Well, they use the simplest language you can possibly imagine: binary. It has just two states, two words. Think of it like a light switch. It's either on, which we call a 1, or it's off, which we call a 0. That's it. Every photo on your phone, every movie you stream, every single thing is, at its heart, just an unbelievably long string of these ones and zeros.
Let me show you what I mean. In our everyday counting system, the number 9 is just, it's 9. But in binary, it becomes 1, 0, 0, 1. Sure, it takes up a little more space, but this super simple on-off language is absolutely perfect for the electronic circuits inside a computer.
All right, so we've got the language, these endless streams of ones and zeros. Now we need the T in IT. We need the actual physical technology that can read, write, and process it all. We're talking about hardware. And the story of this hardware is it's mind-blowing. We started out in the early 1900s with these huge, hot, power-guzzling vacuum tubes. Then, in the 50s, the transistor came along. A total game changer, way smaller and more reliable. But the real revolution? The microprocessor. In 1974, a chip like the Intel 8080 managed to cram thousands of those transistors onto a single, tiny piece of silicon. That right there opened the door for the personal computer.
And you know what's wild? Pretty much every computer today, whether it's the phone in your pocket or some massive supercomputer, has these same basic parts. You've got the CPU, which is the brain doing all the thinking. You've got main memory, or RAM, which is like its short-term memory for whatever it's working on right now. The hard disk is its long-term memory. And the buses? That's the nervous system that lets all the parts talk to each other.
But here's the thing. All that incredible hardware, it's basically a really smart rock without instructions. It can't do anything on its own. It needs a little something extra to bring it to life. It needs the ghost in the machine. And that ghost? That's software.
For a long time, telling these machines what to do was brutally difficult. And that's where pioneers like the amazing Grace Hopper came in. She had this absolutely brilliant and at the time kind of radical idea to create programming languages that were closer to how we think, not just how the machine operates.
And you can really see that evolution here. In the beginning, programmers literally had to write in pure binary machine language. Can you imagine? Just ones and zeros. Then we got a little help from assembly language, which used simple shortcuts like add instead of a string of numbers.
But the real breakthrough was high-level languages that used English-like words. That finally made it possible for millions of people to tell computers what to do. And this led to this explosion of different languages, each one basically a specialized tool for a specific job. You had Fortran in the 50s for heavy-duty scientific calculations. Then you got COBOL, which Grace Hopper helped create for running businesses, things like payroll and inventory. And then came languages like Java in the 90s, which really built the web as we know it.
So we've got powerful hardware, we've got smart software, we have these incredible standalone computers. What's the next logical leap? Well, it's connecting them all together. Let's talk about networks.
You know, the internet we can't live without today started as this government project back in the 70s called ARPANET. And what's so fascinating is what made it take off. It wasn't some grand vision at first. It was a killer app, something so useful that people had to get on board. And in this case, it was simple electronic mail. Email. The basic human desire to communicate is what drove the network's incredible growth.
And you can see this explosion of capability perfectly just by looking at our mobile phones. With 1G, all you could do is make a crackly analog call. By the time 3G came around, we could kind of browse the web slowly. Then 4G was the game changer. Suddenly, we're streaming HD video anywhere. And now 5G? It's not just about making your phone faster, it's about connecting everything, from cars to coffee makers, in what we call the Internet of Things.
Okay, let's put all the pieces together. We've got the digital language, the powerful hardware, the intelligent software, and these globe-spanning networks. When you combine all of that, well, you don't just change a few industries, you fundamentally reshape society itself.
I mean, seriously, just think about your daily life. Shopping on Amazon, that's e-commerce. Googling a random fact, instant search. Facebook, YouTube, AI assistants, online gaming, even working from home, all of it. Every single thing on this list is built directly on top of that IT foundation we've been talking about.
And in the business world, this stuff gets really specialized. Think of a big supermarket. The system at the cash register that rings up your groceries swipe after swipe, that's an OLTP system, online transaction processing. It's built for speed, for handling thousands of little transactions every day. But the massive system back at corporate headquarters that's analyzing years of that sales data to decide where to build the next store, that's a totally different beast. That's an OLAP system, online analytical processing. One runs the business day-to-day, the other analyzes the past to make huge decisions about the future. So when you step back and look at the whole picture, IT has evolved from a simple calculator into what is essentially a global, interconnected brain. For decades, we built tools to help us think better. But now we're building systems that can learn and even create all on their own. They're evolving from just being tools into becoming something more like partners. And that leaves us with one massive and, frankly, pretty exciting question. What are we going to build next? Together.